Our first speaker today is Irene Ferandez. Give me 2 seconds, please. Irene Garcia Ferandez is a graduate in biology from the University of La Laguna in Tenerife. She has more than 4 years of experience in communication and awareness in the field of renewable energies. She is in charge of the ITER's dissemination facilities, and Irene has participated in various national and European projects, mainly in communication and awareness activities. Irene, zero emission road transport, over to you. Thank you very much.
Thank you very much, Paul, and hi everyone. Thanks for attending. Let's get straight into subject, and allow me, please, being the first presenter, to start with a small introduction on our main subject here today, which is hydrogen, the most abundant element in the universe. So hydrogen has basically two markets. The first is industries that use it as raw material to make all the materials. Refineries, chemical and fertilizer industries, metallurgical industries, and this way of using hydrogen is the most used today. In the EU alone, 325 terawatt hour of hydrogen is used every year this way. The second market of hydrogen is as a substitute for fossil fuels, as gas or petrol, and this is the hydrogen sector with an extraordinary growth potential. These fossil fuels currently play, we know that, a predominant role in basic sectors as industry, transport and heating, and are therefore an important clue to solve the pollution puzzle we are confronting today. And here is where hydrogen can and will play an important role, but not just any type of hydrogen. So let's have a quick peek into hydrogen types. Hydrogen on Earth is not found free, but always combined with other elements, forming different type of compounds, like water or hydrocarbons. And to be able to use it, we need to be able to separate it from those elements applying some energy. Depending on the hydrogen compound chosen and the CO2 emissions generated in the process, we can classify hydrogen into three types: gray hydrogen, blue hydrogen, and green hydrogen. Gray hydrogen, let's say, is the most pollutant one. The compound chosen is natural gas or hydrocarbons, and the CO2 emissions are high. Blue hydrogen is a bit less polluting than green hydrogen because it's obtained with coal capture and storage technologies. And then is our green hydrogen, which normally the chosen compound is water and is produced by electrolysis using electricity that comes from renewable energies, as solar and wind. This electrolysis process consists basically on breaking the water molecule into its elements, hydrogen and oxygen, using the renewable electricity. So this type of hydrogen has zero CO2 emissions and is the one that will help to decarbonize the economy, helping to mitigate climate change. Green hydrogen has all the qualities that makes it very interesting for any energy management. And as we can see already, applying energy to the water molecule, the hydrogen has the particularity of being able to store this energy to later be released gradually when required. So yes, we do have batteries today for this purpose, but the batteries are not suitable for storing large amounts of electricity over time when hydrogen is. So we can produce green hydrogen with the renewable energy excess production, which is the one that cannot be used on that moment because the network is in surplus, and then store it and produce electricity later in a fuel cell when is necessary. This quality gives hydrogen buffering capacity that is essential for the penetration of intermittent renewable energies, and all this with no carbon emissions whatsoever. It's easy to see that green hydrogen will play an important role globally, but we believe that it will be even more fundamental in coastal areas due to the common characteristics that makes them more prone to have energy-related issues. Coastal areas are generally isolated, especially if we're talking about islands, whether it's for being at the end of the energy distribution network or because depending on fossil fuels, which can be expensive and vulnerable to supply issues. Due to this, they have large energy dependence and weak grids that result in unstable energy supply. Benefits of green hydrogen technologies can provide easy relief of problems derived from these characteristics. It will allow to generate electricity for use on site rather than transmitting over electric grid, and it will increase the share of renewable energy, enabling the long-distance transportation of energy, which cost much less than power transmission lines. Also opens a big opportunity for green tourism, introducing fuel cell electrical vehicles in car rental fleets, and altogether will greatly reduce imports pressure. All this taken in account, communities will be empowered through the use of hydrogen technologies to control their own mobility and energy systems, both of them essential areas for a healthy and balanced development and sustainability of the communities. Green hydrogen scalability allows smaller communities to get involved and become producers and managers of their own energy, favoring security of supply and allowing communities to have external energy independence. Hydrogen as a vector also allows an easy distribution of energy between sectors and regions. So regions with low-cost renewable energy can export to those that are centers of demand. So up to now, we got a basic vision on hydrogen and understanding of its many benefits. And now we're going to focus on road transport because the transport segment makes up to about 1/3 of all CO2 emissions in the European Union. Its decarbonization represents a key element in achieving the energy transition. And for this task, hydrogen is the most promising option when we compare with the lower energy density, hence lower range, high initial costs, and a slow recharging performance of batteries. First, we will look at hydrogen technology and its focused. Then we go through fuel cell electric vehicles to then finish with a case study. So we'll start with hydrogen refueling stations that are installed or in progress in Europe. We can count around 140 operating, and 90 of those alone are in Germany. Hydrogen refueling infrastructure has two significant advantages. They require only about 1/10 of the space compared to fast charging for batteries, and suppliers can provide hydrogen flexibly, while at scale fast charging infrastructure will require significant grid upgrades. These infrastructure advantages also allows for a fast increase on the number of refueling stations in time, as we can see in this graph. The number of new fuel cell electric vehicles, registrations are shown in this graph for last year. And we can see a clear correlation with the refueling station installation leading countries as Germany, France, and the United Kingdom. Overall, hydrogen technology already exists in most of the segments of the energy system and is ready for deployment today. So we can predict its behavior. And here we have a little focus on the with two possible scenarios for the hydrogen technology vehicles. And basically we can see that most of hydrogen powered vehicles are now available or will become so within the next few years. The infrastructure to fuel this predicted vehicle fleet needs to go hand in hand with the number of vehicles on the road. So here we have a focus for the hydrogen refueling stations in Europe, with about 3,700 large fueling stations in 2030. The fuel cell electric vehicles will be able to provide full mobility across Europe. We need to take into account that the deployment will still require a significant step up of activities to ensure this initial infrastructure is put in place. In transport, hydrogen offers the same range and refueling speed than combustion engine vehicles, although they are essentially an electric vehicle, but that one that gets the electricity from a fuel cell. Here, where hydrogen is combined with oxygen in the air to produce electricity and obtain water as the only byproduct. So here is the tank where compressed hydrogen goes. There is a small battery pack for starting and other small processes, but the rest of the components do not differ much from electric or combustion cars. As we can see in the diagram, the fuel cell electric vehicle technology is fairly technically advanced application and have been proven through extensive testing by researchers to be as safe as to drive a gasoline car. Here we can see some of the applications for this type of hydrogen vehicles as passenger, logistic vehicles, small ones, big ones, buses, and some forklifts. And there are here, we can see some of the several passenger models that are already out on the market. All of them are fuel cell cars, except for the Mercedes that also has a lithium-ion battery. And it's actually for rent, not for sale, and can be used as passenger, private cars, or as taxis. Like, for example, the Hype project that launched 100 hydrogen taxis in 2015 in Paris. This slide shows the fuel cell extended range vans that are often used as logistic vehicles. And here in the next one, we can see the two options to convert all the types of vehicles into hydrogen use. The dual fuel, which basically converts a standard diesel vehicle into using hydrogen, and it manages a reduction of around 70% on CO2 emissions, and the range extension of electric vehicles. Here we got the trucks. For trucks, hydrogen actually has a higher energy density than batteries, so allows these vehicles to drive further and transport more payload than battery electric trucks or vehicles. The driving range today goes from around 400 to 600 kilometers per fill of the tank. Here it's a map of the buses, the fuel cell electrical buses, and as we can see, it's not uncommon their use in urban areas. They really contribute greatly to clean air policy. And here we got two examples, one for urban buses and the other one for long range. Here is the GenCom project, one of the partners of the Triple Alliance, that has put 3 fuel cell electric buses at service on Northern Ireland that would run fully on sustainable hydrogen, and the Caetano bus that was presented in 2019 and is capable to travel around 400 kilometers. And this slide is just to show the refueling of the cars, of the hydrogen cars, and to explain to future customers that is perfectly safe and very quick, and already done around the world for many people. It takes the same time as refueling a gas tank, about 5 minutes for a car and 10 minutes for a transit bus or truck. And the process is exactly as the same as going with your combustion car into station. Yes, hydrogen is compressed, but the storage methods and fueling protocols, as with combustion cars, are fully aimed to ensure total safety. So there is no issues there. Here is a slide with the benefits of hydrogen into road transport, and to illustrate the advantages, we can study, for example, the present case of the hydrogen fuel cell forklifts versus their electric equivalents. Even though they are significantly more expensive, they are an indisputable commercial success thanks to their autonomy, constant power, and recharges in a few minutes. Users estimate that their productivity can easily double that of the battery competitors. They are also especially suitable for indoor operations because they produce no local pollutants emissions and only very low noise and vibrations, and take up less space and are cheaper to maintain and repair. So now quickly to finish, we are going to go into a case study on hydrogen road transport that is currently being developed in the island of Tenerife in Canary Islands, Spain. So Tenerife's population gets multiplied by 5. Here is the population of the island, and 928 inhabitants, and tourists reach up to 5.6 million in 2019. So due to this, it has a big fleet of vehicles in such a small space, around 3,000, the last count. That makes it a much interesting area where to test the sustainable integration of renewable fuels as hydrogen in local transport. This case study is part of the Seafuel project that aims to demonstrate the feasibility to power local transportation networks using fuels produced by renewable energies and seawater with no net carbon footprint. As here we can see a little study of the highways of the island, and also the analysis of the vehicle fleet currently owned by ITER, Institute of Technology and Renewable Energies, that is in the south of the island, and where the technical part of the project will be installed. Two main actions will be carried out at ITER premises. First, the installation of a fully integrated pilot plant for the production of hydrogen from renewable sources, and second, a partial replacement of the fleet of diesel fuel vehicles by hydrogen-powered ones, which will be monitored to report back the performance to the studies. Solar energy from the 51 megawatts of renewable energy installed in ITER will be used to power the a fueling station that will hold around 12 kilos of hydrogen a day at 350 bar, and a desalination plant, because we will be using seawater on this project. As we can see, the plant is very compact, and it has both in it, the hydrogen production plant by electrolysis and the fuel dispenser. Its tank capacity will be around 74 liters. There will be 2 different types of hydrogen vehicles tested on this case. 3 hydrogen fuel cell range extended electric vehicles converted by Logan Energy that will be used as technical crew vehicles at ITER, as well as 2 already commercial fuel cell vehicles from Hyundai and Toyota that will be mainly available for testing. So on this note, I would like to invite you to come and test them at ITER as soon as we have them running and the circumstances allow for traveling and visiting, as well as a thank you for your time, and hope you did enjoy this and will do so as well with the rest of the webinar.
Irene, many thanks for that. A great presentation. And we have a few questions coming in, and I ask the audience to keep those questions. It's also interesting that we have our experts sitting in the wings, Pau, Desi, and Roberto, and they're answering questions as we go along as well. And it shows the opportunity for the Community Hydrogen Forum for engagement. One of the questions I have for you, Irene, is on Tenerife, is it going to be political will or ambition or a mixture of both that will tip the balance in favour of hydrogen as an energy vector?
Sorry, I didn't hear that well. Political or?
Will it be political will on its own, or ambition, or a mixture of both to get over the threshold to use hydrogen as a commercial opportunity?
Well, everything, not only in Tenerife, everywhere, I think everything needs to come together. Politics, industry, and future clients need to all come together. We need to give information out for people to know the technology with forums like this and webinars like this. And definitely politicians needs to have a long-term plan together with industry to make all this happen soon enough.
Also, an important point from Michael Cecil on Rathlin Island, who partners with us, and the Valencia, not the Valencia in Spain, the Valencia off the coast of Ireland, about the Highlanders projects. And Michael raises a point is it's very important that smaller remote communities do not get left behind because the governments favour large-scale projects. On your demonstration, how much of the focus is to distill it down to community use or to regional use, Irene?
Well, we are starting with a very small hydrogen production plant, and the idea of one of the main ideas of this project is to come out with a full procedure for small communities to be able to replicate this here in the Canaries, but anywhere in the world as well. So we fully focus on this part of the project. We are not trying to help build big companies, to get into hydrogen. I think they got enough resources to do that on their own. We can offer them information if they need to, but we fully focus on small communities. Is our main concern.
Yes. There's a question here from Alex Gunt, and the question I'll post to you, Irene, but I'll also keep it for Avril, for Ian, for Rory, and for the experts in the wings. Alex asked the question, is there a programme of works to identify and educate a technology champion in vulnerable communities who can disseminate and inform? So is there a programme of works in the huge project or in Tenerife that can disseminate and inform?
A program to inform everybody?
Yeah.
There is a big part of the hydrogen route, whether it's in Europe or in Spain or exactly in Canary Islands or in Tenerife, by the Cabildo of Tenerife, that there is a big part of informing the population, giving information out to companies, to industries, and facilitating the whole progress. I'm not sure if there is concrete actions already that have been thought on how to do this, but it's definitely a big part of the whole hydrogen movement.
Excellent. There are two questions here. I'll ask Pau or Roberto or Desi to answer online. One's from Marcus Glover, and he's asking about the typical vehicle costs of operating FCE trucks, and he's asking about the economic justification of higher costs. Pau, if you could address that. And there's one from Donald Walker. What is the cost of green hydrogen per kilogram, and how does it compare with alternatives? If Peter Waters is online, Peter, could you answer Donald's question there online, please? Irene, many thanks for your presentation. There's some fantastic comments there coming in, hopefully not just off your own project, from all of the audience. It gives us a great insight into, whilst Tenerife is an island, it's quite a large island compared to some of the audience today, but it shows how, as I said at the start, the hydrogen solution is different for every region and different for every community. Yep. Thank you very much for that.
Pleasure.